As we go on to Chapter 5, Section 6, here we're dealing with those special products. And we're factoring these special products. And you recall there were two types. One was the perfect square trinomial, and the other was the difference of perfect squares. These were our special products. 1 through 4 is matching, but we're going to move right into some factoring. And what they ask us for number 5, is this a perfect square trinomial? Now notice, the first term is a perfect square, the last term is a perfect square. But when you take the square root of 81 and you get 9, and double it, you get 18 in the middle. And the answer is no. So this is not a perfect square trinomial. Now, number 6, and we can't forget what we have learned in other sections, is this in standard form? No. First thing we have to do is put it in standard form. Now, is this a perfect square trinomial? Well, that's a perfect square. That's a perfect square. If we take the square root of this, we get 4. If we double 4, we get 8. Yes, this is a perfect square trinomial. So this is going to be a y from this. You take half of that and put it here. Or the square root of that, put it there. And if you, foil that or do that special technique, square this, multiply these, double it, square that, it checks out. Again, in number 7, and what I'm doing is anything where it's a little different, I will illustrate it for you on this video. Is there a common factor here? Yes, 2. Now, once we factor out a 2, this is a perfect square trinomial. Now, you need the 2. And again, whatever the middle sign is, that's what's going to be here. This is just an A, and then half of that, or the square root of that, and then you could multiply that and see if it works out, and it does. Now, this one is backwards, and I noticed that in the book, the answer key, and again, the answer key is in the back of the booklet, they have it this way. So we can actually factor it this way. This is a perfect square binomial. Middle term is going to be negative. So half of that, or the square root of that, is 5. And you could have written it this way too. All right, this one's a little different, but it is a perfect square trinomial. Middle sign is positive. This is going to be a y. Now the square root of that is, I should say, that's going to be, oh, probably that's supposed to be an x there. Apologize for that. Copied it down incorrectly. So x, and then this is 2y. Let me just double check that. Actually, this was, but this is good this way too. Okay. This one, is there a common factor? Yes, and it's not quite in the right order. So I'm going to factor out an x. and this becomes x squared, I'll put it in the correct order, plus 20x plus 100. So I should probably put it in standard form, but I did that mentally, and then I factored out the x. Middle sign is plus, square root of that is 10, or half of that is 10. And as you master this skill, you're going to be able to do things more quickly. Going on now to the second part of this, which is factoring special products. In this case, we're factoring the difference of perfect squares. And as we look at number 12, they're asking us, is this the difference of perfect squares? Well, this first term is a perfect square. This term, 1, is a perfect square, and there's a negative sign between them. So, yes, this is the difference of perfect squares. And let's factor it while we're here. And if you recall that when you factor the difference of perfect squares, it factors into a plus b, a minus b. That is their conjugates. And if you multiply conjugates, they result in the difference of perfect squares. So we'll need two sets of parentheses. Take the square root of that, which is 2t, and if you recall, square root of 1 is 1. 1 will be a plus, and 1 will be a minus. That's the system of these conjugates. Now, as we look at number 13, again, this is a perfect square, and this is a perfect square. So we will factor it into its conjugates. And again, you're going to develop whatever skill you can to do it. Square root of 9 is 3. So you can put a 3 in each of those places. And then taking the square root of this is mn, and 1 will be a plus, and 1 will be a minus. Now remember, you can put the negative here and the plus there. It doesn't make any difference. I prefer to put the plus in the first one. Now again, the skills that we've worked on is, when you look at it, is there a common factor? And for number 14, yes, a common factor of 5a. And once you take the 5a out, you're left with a b squared. And a 5a out of here, you're left with a 4. And now there's your difference of perfect squares. So the 5a comes along, two sets of parentheses to write your conjugates in, b plus 2, b minus 2. As we look at number 15, we see there is also a common factor of 15 that we're going to factor out. And we get x to the 4th minus y to the 4th. And those are perfect squares. We factor it into our conjugates. And here you notice something. I saved you the cough on the tape. That in this conjugate of this is still a perfect square, the difference of perfect squares. So this will factor into, one more time, this one, which is the sum of perfect squares. That doesn't factor, but the difference of perfect squares does. And you would need to bring it all the way to here to get full credit. I'll just check to be sure we're recording there. Okay, yes. Now, as you look at number 16, again, it looks rather complex, but 64 is a perfect square. But then you see an x squared and x to the 6th. So here we could factor out an x squared. And then we're left with 64 y to the 8th minus 25 x to the 4th. So there's our perfect squares again. Set up our conjugates. 8y to the 4th plus 5x squared. And then 8y to the 4th minus 5 x squared. And that's our answers.